Hello everyone, welcome back. In this video, we'll be taking a look at absolute values. So, so the definition of absolute values, and remember this: absolute values can also be called as modulus. So the definition of absolute value, as we know, is it always spits out a positive number. So if you put in a positive number, you get a positive number. If you put in a negative number, you get a negative number. So this is the more or less the definition of it. So if you put in x, which is a positive number, and for example, if x is when x is greater than or equal to 0, that means it's a positive number, such as 3. Then you get a positive, you get the x itself, the number itself, such as which is 3. But if you put in a negative number, when x right here is negative, such as -3, when x is less than 0, you get the negative of x. So you get negative of -3. You get 3. So in both cases, when x is greater than or equal to 0 or x is less than 0, you always get a positive number. So that's basically the definition of absolute values. So the first part is a bit easy to understand. So let me explain the second part once again to make it more clear. So when x is negative, when the value inside the modulus is negative, for example, if it's -9, then you get that negative x, you get negative of the negative number, so you get negative of -9, so which is 9. So you always end up with a positive value. So let's take a look at some theorems involving absolute values. So the first theorem states that modulus of xy is the same as modulus of x times modulus of y. So remember this: more likely or not, when we're proving theorems involving absolute values, you should be the correct proof, more likely or not, will be involving cases. So there are 4 cases in this case, and remember that. To know the number of cases to work with, always just take the number of variables and square them. So in this case, we have 2 variables, so you square them, you get 4. If you have 3 variables, you'll have 9 cases, and so on and so forth. So the first case we'll be working with is x being greater than or equal to 0 and y being greater than or equal to 0. So if x is greater than or equal to 0 and y is greater than or equal to 0, so we have to prove that the left hand side is equal to the right hand side. So we get that the left hand side, if you multiply two positive numbers, you get a positive number. So you get xy being xy, which is positive. And you get the right hand side. Remember that, so the positive number will stay as it is. So remember from the definition of the absolute values, a positive number, if x is greater than or equal to 0, if the value inside the brackets is positive, you get the number itself, and if it's negative, you get the negation of the negative number. So since xy is positive, you get the number itself, and since x is greater than or equal to 0, you get modulus of x being x, you get modulus of y being y, and multiplying modulus of x times modulus of y, which is the right hand side, you get xy. The left hand side is equal to the right hand side, and we're done with case 1. So now we have to prove case 2. So case 2 will be when x is less than 0, when x is greater than or equal to 0 and y is less than 0. Sorry about the handwriting right there. So then we'll have, since we're multiplying a positive x with a negative y, we'll get that xy is negative. And since xy is negative, from the definition of the absolute values, whenever the value inside the absolute value is negative, we take the negative of the negative value, so we get a positive. So since xy is negative, so we should take negative of the negative xy to get a positive. So we get that modulus of xy. Remember this xy is negative because y is less than 0 and x is greater than or equal to 0. So this xy is negative. So we take the negative of xy. So we get negative of the negative value of xy, so being positive. So note that this negative xy is a positive, and we get that the right hand side, the modulus of x will remain the way it is, and modulus of y, since it's less than 0, you take the negative of it. Now negative y is also positive, and multiplying both of them together, you get negative xy. You get the left hand side is equal to the right hand side, and we're done with case 2. So let me explain once more why we take modulus of y as being negative y. So if y is, since y is less than 0, for example y is negative 7, and from the definition of the absolute values, whenever it's the value inside the modulus sign is negative, in this case when y is negative 7 for example, and since the value inside it is negative, you take the negative of the negative value. So you take negative of negative 7, so you always end up with a positive number. So that's why you take negative y. So let's take a look at case 3. So case 3 is when x is less than 0 and y is greater than equal to 0. So this is similar to case 2, so we'll follow the same template. So we get that xy is also negative in this scenario. So xy is negative since we're multiplying a negative number by a positive number. So xy is negative. From the definition of the absolute value, you'd always take the negative of the negative number, so you end up with a positive. So you take negative xy. So negative xy is now positive, and you get modulus of x. Since x is less than 0, x is negative, so you negate the negative to get a positive. You take negative x, and now a negative x is now a positive number. And modulus of y, since y is greater than 0, it's positive, it remains the way it is. And modulus of x times modulus of y, which is right hand side, is negative xy, and left hand side is equal to the right hand side, and we're done with case 3. Case 4, in the last case, is when both x is less than 0 and y is less than 0. And since, so the left hand side xy will be positive. Since we're multiplying two negative numbers together, we'll end up with a positive number. And from the definition of the absolute value, whenever the value inside the absolute value is positive, it remains the way it is. So we'll get xy. And the right hand side, so this is the left hand side, the right hand side, we get that modulus will be negative x and modulus of y will be negative y, because since both of them are negative, so we take the negative of the negative y to get a positive. So for example, y is less than 0, you take negative of negative 9 to get a positive 9, right? So multiplying both of them together, you get negative x dot negative y, which is xy, and you get left hand side is equal to right hand side, and we're done with the proof of this theorem. So let's take a look at how we can prove the same theorem in an alternative way. So for that, I want you guys to note this lemma, which we're not going to prove but we can prove, but I want you guys to do it as practice. So we can take modulus of xy as xy whole square. You can further write this as modulus of x squared y squared, and this breaks down to modulus of x squared dot modulus y squared, and from this is the same as modulus of x dot modulus of y. Well, this is a simple way to prove this, but I didn't choose to do this because we'd have to prove this anyway using cases. So more likely or not, when you're proving theorems involving absolute values, you'll have to work with cases, or you can use this squaring method. So this theorem can also help us prove this other theorem or lemma, which is this. So we can simply write this as modulus of x y inverse, and we know this is the same as modulus of x times modulus of y inverse since we proved this, and this is the same as this, and we're done. So let's take a look at another theorem. It says that modulus of x is always positive. We know this is pretty trivial. Let's take a look at how we prove this. So again we'll be working with cases. So case 1 is when x is greater than or equal to 0. The value inside the absolute value is a positive number, and from the definition of absolute values you get that modulus of x will be x. It'll be x itself, and x we know is greater than or equal to 0. So from case 1 we've proved this. We always get it being greater than or equal to 0. And case 2 is when x is less than 0. So when x is less than 0, it means x is a negative number. For example, x is negative 7. Therefore, from the definition of the absolute values, the negative x will be greater than 0. So negative x will be negative of negative 7, which will be 7, which is greater than 0. So we get that modulus of x equal to minus x, and minus x is a positive, and therefore it's greater than 0, and we get modulus of x is greater than or equal to 0, and we're done with the proof. Since we've proved for both the cases that modulus of x is greater than or equal to 0. So let's take a look at this theorem. It says that modulus of x minus y is the same as modulus of y minus x. So let's take a look at this using cases again. So if x minus y is greater than 0, then y minus x will be less than 0. For example, if x equals to 5 and y equals to 2, x minus y is 5 minus 2, which is 3, is greater than 0. But y minus x is 2 minus 5 is negative 3, is less than 0. So if x minus y is greater than 0, then y minus x will be less than 0. So since x minus y is greater than 0, the left hand side will remain the way it is since it's positive. That's the definition of the absolute value. The right hand side will be, since it's a negative number, you take the negative of the negative y minus x to make it positive, which is x minus y. So you get left hand side is equal to right hand side, and we're done with that. So if it's the opposite way, if x minus y is less than 0, then y minus x will be greater than 0, and you get that modulus of x minus y from the definition of the absolute value. Since the thing inside it is negative, you should take the negative of the negative to make it positive. You get negative x minus y, which is equal to y minus x. You get modulus of y minus x, which is positive, so it will remain the way it is. So the left hand side is equal to the right hand side, and we're done with the proof. So let's take a look at one last theorem before we end the video. It says that modulus of x square is the same as x square. So you might have guessed already, we'll be again working with cases. So the first case we'll consider is, of course, when x is greater than or equal to 0. So when x is basically a positive number. So when x is a positive number, from the definition of absolute values, what's inside it will remain the way it is. So you get is x. So modulus of x square can be written as modulus of x dot modulus of x, which is x dot x, which is equal to x square. So we've just proved modulus of x square equals to x square when when the thing inside the modulus is positive. And case 2 is when x is less than 0. You get that modulus of x will be negative x. So let me repeat this one more time. When x is less than 0, for example, x is negative 100. So x here, right here, is negative. So you should take the negative x. So negative x will be negative of negative 1000, which will be 1000, and this is positive. So that's why we take negative x. So this again, modulus of x square can be written as modulus of x dot modulus of x, which is minus x dot minus x, which is equal to x square. And we've just showed that modulus of x square is equal to x square when also the things inside it is negative. And we're done with the proof. So hope you guys have enjoyed this video. See you next time.